Sun gives us vast amount of energy which can be converted directly or indirectly into other forms of energy such as heat and electricity. Solar photovoltaic systems are employed to harness light energy of the sun by directly converting it into electricity. One of the important applications of the solar photovoltaic systems is solar lantern. In the areas where power supply is limited, solar lantern can be used to provide light. The heart of solar photovoltaic lantern is solar module. It is made up of solar cells connected in series and parallel arrangement. Let us now see the assembly of solar module. Solar cells are made from semiconductor material silicon, which generates electricity when it absorbs light. At open circuit, 0.6 volts is the maximum voltage of silicon solar cell. During sorting, voltage and current ratings of each solar cell are checked as per standard specifications. Next step is dabbing of solar cells. In this process, a small and thin tin-plated copper strip is soldered to the bus bar of the solar cell so as to collect the charges to pass them onwards to the electric load. The next process in the assembly of solar module is stringing. In stringing, combination of solar cells is carried out to form the solar module. The individual solar photovoltaic cells are connected in series or parallel combination as per specifications of the solar module. The solar module of 10 peak watts is generally used in solar lantern. After stringing, layup is the fourth step in assembling process. Layup process involves the usage of two sheets. These are the Tedler sheet and the EVA sheet. In layup process, solar cells are encapsulated with EVA and Tedler sheets to protect it from atmospheric degradation. These sheets are cut as per required dimensions. Toughened glass is used to provide a clear, weather-tight front covering to the solar module. Toughened glass has high transmittivity for solar radiation and it has high strength as compared to an ordinary glass. This glass allows most of the solar radiation to fall on solar cell module, and on absorbing these radiation, free electrical charges are generated in the silicon solar cell. Both sides of the solar module are covered with anti-reflective ethyl vinyl acetate sheet for its protection. The backside of the solar module is covered with Tedler sheet, which is moisture resistant and has high mechanical and shear strength. After completion of this task, the solar module is inspected. Next step of manufacturing process is vacuum lamination. The module is placed in the lamination machine. In this machine, the solar module is treated at the temperature of 100 degrees Celsius for 5 to 6 minutes for proper binding of the module. After lamination, curing is done. Curing gives strength to the solar module so as to withstand extreme climatic conditions. Here, the modules are heated up to 150 degrees Celsius for 25 to 30 minutes. Thereafter, edge trimming of solar module is carried out. Extra EVA and tabular sheets which are beyond the glass edge are cut and removed. Last step in assembly of solar photovoltaic module is its testing. The solar module is tested with the help of an electronic simulator machine. Various current and voltage ratings of solar module are tested and checked with standard ratings and specifications. Assembly of solar lantern. Solar lantern is housed in aluminum or plastic body. On the lantern base, sealed and maintenance-free battery is fitted. The battery generally used in solar lantern is of 12 volts and 7 ampere hours. Proper cushioning is made before placing the electronic circuit card on it. This card includes a high-frequency inverter and charge controller circuit. The inverter is protected from short circuit and open circuit. Thus, in case the battery is low, the lamp will switch off automatically, thereby preventing deep discharge of the battery. Also, while charging, if the battery gets overcharged, the charging will be disconnected automatically. This electronic circuit is further connected through connectors to the compact fluorescent light tube and the battery. The battery is used since the sun's energy is available during daytime, whereas Its application is during night. The DC electricity produced during the day is stored in battery. This stored energy is delivered as electricity upon discharge. After these connections, along with the earthing strip, compact fluorescent light tube of 7 watts is fitted on the tube holder. After its checking, acrylic chimney is fitted over the compact fluorescent lamp. This completes the assembly of solar lantern, which is now ready for use. Charging of solar lantern. Solar photovoltaic module is connected to solar lantern through plug and socket arrangement to charge the battery. When sunlight falls on the top surface of solar cells, it is converted into DC electricity due to photovoltaic conversion process. The electricity thus generated is stored in storage batteries to be used later. The glowing of green LED indicates that the charging of battery is in progress. All this is required to be done since the sun's energy is available during daytime, whereas the solar lantern is used at night. During charging, care should be taken that solar photovoltaic module should face the sun and no shadow should fall on it. It is advisable to switch off the compact fluorescent light tube during charging. Generally, it takes 5 to 6 hours for charging of battery of solar lantern on a normal sunny day. And with this, the daily average operating time of solar lantern is 3 hours per day. Solar lantern is similar to the conventional lantern. It is practically maintenance-free. However, while using it, some precautions are required to be taken. These include: keep the lantern upright away from heat and fire, charge the lantern every day, do not ever connect lantern cable into power supply or AC mains, wipe the solar module and lantern with cotton cloth to clean the dust, and finally, do not ever clean the module and lantern with detergents and acids. To meet the energy demand, especially in rural, remote and unelectrified areas, solar photovoltaic lantern provides a viable solution.
हम इसे पिछले 4 सालों से इस्तेमाल कर रहे हैं। ये हमारे लिए बहुत ही लाभदायक है। अक्सर हमारे गांव में लाइट चली जाती है। ये हमारे रोज़ रोज़ाना के काम जैसे कढ़ाई, बुनाई और रसोई का काम, पढ़ाई वगैरह में बहुत ही उपयोगी है।
The solar lantern operates on solar energy. It consumes no fuel. It does not create pollution. It has long effective life. Thus, it holds a lot of potential to meet our energy demand of lighting.